Good afternoon, everyone, and a warm welcome to you from the Faculty of Science and Technology here at the University of the West Indies, Mona campus in Jamaica. A special welcome to our panelists, members of the private sector and the general public here in Jamaica and across the Caribbean. We are happy to have you join us for our Science for Today series, exploring the title Down to the Last Drop, Tackling Jamaica's Water Woes. Your presence today reflects a shared commitment to finding sustainable solutions to benefit our communities, livelihoods, and our country. Water is essential for life, and climate change has created much uncertainty about the future sustainability of water resources. Many communities, industries in Jamaica face persistent water-related challenges. In this forum, we aim to delve deep into the root causes of these issues and explore innovative and sustainable solutions. We have a diverse panel of experts and stakeholders who will share their insights and experience. I encourage everyone to actively participate, ask your questions, and share your thoughts. Let us together find lasting solutions to Jamaica's water woes. Our first panelist will be Mrs. Jacqueline Spence. She is from the Meteorological Service of Jamaica, where she has over 21 years of service and currently serves as the head of the Climate Section branch. In her capacity, Mrs. Jacqueline Spence Hemmings is responsible for the management of the data collection network, which covers the length and breadth of the island, as well as engaging in research activities in the development of climate services and products to inform the decision-making and the resilience building of Jamaica's various sectors. Mrs. Jacqueline Spence Hemmings, you may now have the floor.
Thank you and good evening, everyone. So let me start sharing. And can you see my slides?
Yes, I am seeing your slide.
Okay, good afternoon again. So I don't know, but you're not getting the first slide. So the presentation is entitled, I'm just kind of asking Jamaica, the land of wood and water, are we having water woes? And I will start with an introduction. The Meteorological Service of Jamaica is a member of the World Meteorological Organization, which is a specialized agency under the United Nations. Here in Jamaica, the Meteorological Service is a branch of the Ministry of Economic Growth and Job Creation. The Meteorological Service consists of 3 sections, namely the admin and support services, the weather section, and the climate section. The weather section, most persons would interact more closely with that section, and they are responsible for issuing your daily forecasts, etc. The climate branch, on the other hand, is responsible for monitoring the data collection network across the island. In addition, we develop reports and do analysis of data to inform research and other activities. Additionally, we develop climate services and products for decision-making to various sectors. On screen, you are seeing a map of our station network, and this includes automatic weather stations as well as manual rain gauges. So some of the products, as I mentioned before, from the weather branch, you have like your daily forecasts. You are also familiar with warnings and watches, which are usually issued for severe weather events, which include storms and hurricanes. For the climate branch, however, we have drought monitoring and forecast, but for us, our forecast will be on a longer time scale. So for instance, we'll issue 1 month, 3 months, 6 months, etc. forecast. And we also do that for precipitation and temperature. And we also have a bushfire index, which is still in pilot phase. So to look a bit at the climatology of Jamaica, we look at the air temperature, and this graph is showing your minimum, mean, and maximum. And if we look at the smallest dotted lines for each of these indices, which would be the year 2019, we'll see that you first see the variation of temperature throughout the year. And we do see that for the most part, our temperatures don't vary very significantly. Of course, we do have our microclimates, for example, the Blue Mountain area. So your highest temperatures are around, summer months, June to about October. And we do see, however, that there is also this change in temperature that is occurring, because this graph is showing data from 1929 to 2019. These were developed for these years. So we're seeing an increase in these temperatures taking place. And this is especially significant for the minimum temperature. So we're seeing that the minimum temperature is showing the greatest increase over the years considered here. Looking at the rainfall pattern, we immediately see a bimodal pattern here. 2 peaks, one early rainfall season around April to June, the other around August to November. And August to November represents the primary rainfall season, and it also coincides with the most active part of the hurricane season, whereas April to June is the secondary rainfall season. We also have a dry season from December to March and a midsummer drought in July. This map shows the rainfall distribution over a 30-year period. The period being considered here, 1971 to 2000. So we see the wettest part of the island in the east, the west, and coming into the hilly inland areas. However, as we go out to the coastal areas, we're seeing where, those areas are drier. So those areas get less rainfall. Looking a little bit more on the season, as we mentioned, December to March would represent our dry season. And for that same period, 1971 to 2000, we see that you have a wet signal over Portland area. However, for the most part, the greater portion of the island is very dry. So, yes, it is our dry season, but, we still need to have rainfall. But we are seeing here that, over the mean, it is the rainfall that we do get during this time is very little in most parts of the island. Now to look at 2023. So I think everyone remembers 2023, it has gone down on record. And this graph is showing a comparison of the rainfall that we received in 2023. That's the red line. And the brown line is the 1971 to 2000 mean that I spoke about before. And we're seeing how far below the mean we fell for last year, which speaks to why we saw the issues we did, and can only imagine, the challenges that we faced throughout the year. So some of the contributing factors to last year was the El Nino, being present resulted in mainly drought conditions across the island. Of course, El Nino affects different places differently. However, for the most part, Jamaica does have drought conditions. We also had higher temperatures, and I mention temperatures here because global warming is already giving us warmer temperatures, and El Nino created additional warming on top of that. So last year was warmer than normal, so much so that we saw the government allocating significant funds for drought as the crisis deepened. We see water crisis for St. Catherine, but we also saw our minister indicating that, you know, the water problem wasn't just a city problem, it was across the island, which was indeed true, based on the graph that you saw just now. We also heard of bushfires, and persons might say, yes, but we're talking about rainfall. But yes, we have the outbreaks of fires being more likely because the ground is very dry. So therefore, you know, persons have to be sure that they monitor their practices when during this period, and you would see from our Minister Desmond McKenzie indicated that 99% of bushfires were caused by human error because, you know, we're having drought, significant drought across the island, but persons were not cognizant of their activities to ensure that, you know, they don't contribute to the problem or exacerbate the problem. On the flip side, we saw JPS making record profits from summer heat. So yes, the rainfall wasn't coming as we wanted it, and the temperatures were higher, and that combination is very significant because apart from JPS recording profit because persons had to you know, be running the ACs and the fans and finding various ways to remain cool, it also meant that evapotranspiration rates, especially the farmers, could tell you that, you know, the minute some water gets on the plant, a day later, it's all gone. So, you know, the soil moisture was being lost a lot quicker. So we have a combination of impacts. So not having the replenishment happening as it should, the higher temperatures only exacerbated what was already a very serious problem. So WMO confirmed that 2023 smashed the global temperature record. 2023 has gone down as the hottest year on record. And as I indicated, although this is temperature and we're here talking about water, they are very much related and we can't consider one without the other. So let us look a little bit at what is being done globally. So the Intergovernmental Panel on Climate Change, IPCC, is the United Nations body which assesses science related to climate change, and they provide regular assessments of the scientific basis of climate change. They look at impacts, future risks, options for adaptation, and mitigation. Findings from these assessments inform the United Nations Framework for Convention on Climate Change. And to note that we have several persons from the University of the West Indies who have been authors in the IPCC process. And the global warming report of 1.5 degree highlighted that climate models project robust differences in regional climate characteristics between present day and global warming of 1.5. So we're not there yet. And if 2023 was as hot as it was, we can only imagine when we get to 1.5 what that will mean. Because remember, 1.5 is a global temperature. On a local scale, your temperature will, you know, vary across the world. They also indicated that hot extremes in most inhabited regions, heavy precipitation in several regions, and the probability of drought and precipitation deficit in some regions. And you see the confidence levels, high or medium confidence. It was indicated that several regional changes in climate are assessed to occur with global warming up to 1.5 when we compare that to the pre-industrial levels. And this includes warming of extreme temperatures in many regions, increase intensity and in frequency of heavy precipitation, which we know we're already seeing. We're seeing intensity and frequency of droughts in some regions as well. So based on that report, there is definitely a call to action. We believe that current past events, coupled with the projections indicated by IPCC, there is clearly a need for urgent and impactful action. The climate risks indicated will depend on the magnitude and rate of warming, geographic location, levels of development and vulnerability, and the choices of implementation of adaptation and mitigation options. Another statement from the IPCC and high confidence. So what is the response from the government of Jamaica with regards to all that has been happening? Well, an integrated water resource management council was formed because it was noted that the impacts of climate change on water availability and water quality affects many sectors and has impacts for infrastructure, human health, agriculture, and ecosystems. The changes in weather patterns will, of course, affect water supply, and below average rainfall levels result in persistent drought across the island, similar to what was seen last year. So the government also noted that a traditional fragmented approach where we do things in silo could no longer be the way to approach the issue at hand. So the rationale behind the IRRMC was that which is now accepted internationally, is that they have a holistic approach to water management. So the IRRMC seeks to facilitate broad-based consultation of key stakeholders on matters relating to water and water-related resources, and they serve as the advisory body for the management of the island's water resources. So the areas of focus include, but are not limited to, water and climate change, water and energy, water and agriculture, water, wastage and sewage services, water and health, and watershed management. So I started with a question and I will end in a similar way. Are there water woes in the land of wood and water, or is this all just temporary occurrences? Do we think that only the government is responsible for finding solutions? Or will we choose to remain in what is called the hydrological cycle, where, once we have drought, there's awareness, concern, panic when it gets worse, but the minute we get some rain, we get complacent, forget about it, and the cycle goes around again? Some things to ponder. I thank you.
Thank you very much, Mrs. Spence Hemmings, for your presentation. It truly provides us with a context on the state of our local climate, as well as some of the initiatives that the government is pursuing to tackle some of the water issues that we are facing. So now we have Senator the Honorable Matthew Samuda. He will be our second speaker. He is currently the minister without portfolio in the Ministry of Economic Growth and Job Creation. He is assigned portfolio responsibilities for water, environment, climate change, and the blue and green economy. Minister, welcome.
Thank you so much for having me. It's indeed my privilege to join the list of speakers that you have this afternoon, and I think it couldn't be a more opportune time. Allow me to acknowledge certainly all of the members of staff at UWI who are present, as well as all other persons who are presenting today. The request came in a few days ago, and the first line of the presentation written for me from my team would have said, as Jamaica is experiencing particularly dry times. And I think regardless of where most of you would be digitally this afternoon, those dry times would have subsided, even if it is briefly. Jamaica is at an interesting point in its developmental journey. Where there are several errors, and depending on what you evaluate, you will look at particular errors. And in one context, you would refer to this period in our developmental journey as the post-IMF bailout era, because from an economic perspective, we would have had a series, and every decade would have had its own economic bailout from the IMF. I think post-2013, this is the first decade that we've not needed an IMF bailout. So it's the first time Jamaica is building the sort of economic resilience that allows you to have particular conversations. So the first thing I checked in looking at what I would discuss with such an auspicious panel, and certainly those would be interested today, was I looked back at the Water Resources Master Plan, which should have been tabled last year, I think towards October, November. Have been produced by the Water Resources Authority. And I refreshed my memory just to confirm one very important fact, which is that Jamaica still, with the climatic changes that we've had at a 1.2 degree, give or take, temperature rise, Jamaica still has sufficient fresh water to satisfy its needs. And its extraction ratios do give you some latitude in terms of how you extract and how you deal with that fresh water. Jamaica's crisis has not yet purely been for climatic reasons, though that will change, I believe, in the short to medium term. It has been because of economic reasons. Jamaica simply has not invested in the water-related infrastructure that it requires to ensure that you have sufficient potable water, sanitation access, and irrigation water for its population needs. That's just impatient of debate. If we look at the two main infrastructure items that form a part, certainly, of our Kingston and St. Andrew water supply, one, for instance, would have been built 95 years ago, which is the Hermitage Dam. The other is the Mona Reservoir that certainly the entire UWI community would be very familiar with. That was built pre-independence. I believe it's 70 to nearly 80 years old at this stage. And if we think of the water infrastructure investments since that time, it's completely inadequate to service the needs of our people. And, that would have contributed to and been because of our developmental challenges and where we are in our developmental journey. And that's not something that we should be shy about. We're a young nation. We would have challenges. We wouldn't have an endless fiscal capacity to build in these systems. But the reality is that we have not invested in line with our own developmental growth. Now, what would that have led to? Chronic lack of investment in our water systems. Well, despite having thousands of hectares of irrigable land, we have not built in the irrigation systems in St. Elizabeth, in Trelawney, in St. Mary, in St. Anne, in Clarendon, that would make our land productive for an economy that depends on agricultural output. If we think of the fact that NWC has a utility footprint that should be able to service 85%, but services about 75% of citizens with that utility footprint, we see the significant gap there. If we look at the state of municipal water systems that would deal with many of our rural communities, which takes us up to about 90% of persons having access to potable water through utility systems, we see that we still have significant gaps. And if we look at our water systems in the context of errors, we discuss the water system, certainly for Kingston and St. Andrew, now in the context of pre and post non-revenue water projects, the pre and post NRW era in Kingston. And I think this is an important part to really dive into the subject here, because the last drop suggests a climatic disaster, which is obviously where we're headed as a world, but not where we are locally. What we have is a utility disaster because of lack of investment at this current stage. Now, it doesn't mean I'm not petrified about some of the climatic models that are presented, but that's not the current issue or the issue over the next few years. It's really the economic factors that have led to debilitating or the utility and its ability to supply. So think of Kingston and St. Andrew. Kingston and St. Andrew in 2015 had a non-revenue water score of 72%. Non-revenue water, curious term, when I took over the water portfolio, I found it very strange. Non-revenue water refers to water that either leaks or is stolen from the utility. Now, there's no business on earth that can run with 72% leakage, but that is what the NWC faced as it related to supplying its 1 million customers in Kingston and St. Andrew. Now, we started a pilot. Previous administration would have led on this. This would have run from 2015 to sometime last year. And that project has cut leakage from 72% to approximately 38%. Now, what does that mean in practical distribution? It means in 2015, Kingston and St. Andrew required the NWC to provide 55 million gallons of potable water a day to its network. Fast forward to 2024, pre the drought, early January, where we had no restrictions, NWC was called upon to supply 38 million gallons daily. Now, we have cut that need by reducing our leaks significantly. We believe we'll be able to get below 20% over the next 2 to 3 years, which will also preserve every last drop that we have and that we currently collect, currently produce, currently store for the corporate area. And the corporate area for me nowadays is Morant Bay to Old Harbour. You know, we create these parish boundaries in our head, and there's obviously real historical and cultural reasons for some of them, but from the perspective of the utility, we don't see those sorts of boundaries. It's really based on where the sources are and what our ability is to distribute in a piece of geography. But we have to consider that 55 million gallons to 38 million gallons by cutting leaks and still being at 38%. It means our distribution network is at the core of the challenges we currently face. And that is not something that I'll resile for. So when you have the conversation with the common man, the first comment made is Jamaica needs another reservoir, needs another dam. And I believe they are right. However, to build another dam, we absolutely must cut the inefficiency and the leakage from our distribution network. And to preserve the very last drop and to ensure that no drop wastes, because indeed every last drop counts and water is life, and we can find all the buzzwords and all of the appropriate terms. We know we have to fix our distribution network. In Western Jamaica now, there's a chronic drought, and they've had negative impacts from reduced rainfall as far as October last year. And Ms. Hemmings will have gone through all the varying climatic results, or rather the facts, the reports from the Met Service, and we see the reduced rainfall and the heat increasing, etc. But Western Jamaica is facing a very tough time. But what exactly is the infrastructural ability to respond to it? Well, Hanover has an NRW score of over 70%. So despite having lower rainfall and having lower intakes to our respective systems, we're also pumping 70% of it into the ground. Now, people say, well, why don't you just fix the distribution then? Well, the reality is it's the very first time, certainly in our economic journey, in our developmental journey, that we have the capacity to contemplate fixing this distribution network. Jamaica has advertised through the National Water Commission in an open public tender that allows for international participation for an international partner in a national non-revenue water program that we expect to pump some $300 million into over the next 8 to 10 years to deal with our major distribution needs. That's because we know that we just have to absolutely cut our wastage and make sure that what we're actually extracting and what Peter and his team at WRA gives us license to extract is indeed used in the most efficient way possible. And we're doing that. We have massive investments even outside of the NRW project that we have contemplated to replace major transition mains even before that procurement is indeed complete. So if you drive along Mandela anytime over the last 5 years, you will see this huge blue pipe that brings water from the Tullow Springs into Kingston and St. Andrew. If you have the chance to drive on Spur Tree Hill, you'll see that significant pipe work has gone on and continues to go on, carrying water from the Pepper Wells into Mandeville. If you drive along the north coast right now from, I believe, somewhere near Miami Bay, all the way going out towards Salem, you will see the impact of pipe laying work going on. So we're dealing with our major distribution mains, and we have internal NRW work that will continue even outside of this major project, because we've accepted NRW as our primary enemy in dealing with the water crisis that Jamaica faces. But that's not the be all and end all, and it's not to oversimplify the issue. Jamaica just simply does not have sufficient storage also for the water that it collects, and we've applied a range of strategies to deal with this. The first, I would say, is at the bigger mass investment level. The first point to contemplate is that in the early 1920s, the then colonial government started designs for the Mahogany Vale system, which contemplates taking water and damming the point at which the Negro River and indeed the Yalas River merge in Hagley Gap, and building a massive dam there that could be able to supply some 100 million gallons into St. Thomas and into Kingston and St. Andrew. That is a project that we believe, its time has come. That project contemplates a hydroelectric component, several tunnels, connections into the Yalas pipeline as it's designed now. That's why Mr. Seaga would have done that in the 1980s, as well as tunnels that carry water to the Hope treatment plant. So there are a number of elements to it. What you have at Mona Reservoir is actually an element of the Mahogany Vale system as contemplated in the 1920s. That's one element of storage. The second major element, certainly for the corporate area, contemplates a new dam in Hermitage. Hermitage was built with a 50-year engineering guarantee. It is now 95 years old. It is time to replace that dam wall. There is a tree root in the base of the wall. It is a risk. It's a national risk. And we're doing the engineering this year with about approximately, I believe, $150 million to do the design work and to start to design the transaction so that we're able to go to tender in the next year or so and look at expansion as well as replacement of that facility. We expect to go out whether, I don't know what the final engineering will show, maybe 200, maybe 300 meters from the current dam wall, and that will significantly expand the capacity, because in building that new wall, it will give us the space to also desilt current system and increase capacity significantly, maybe upwards of 250 to 300%. We'll see what the final numbers come to. So that's major storage in Kingston and St. Andrew. We also expect to build a small dam in Rock River, Clarendon, and we're looking at systems that could use reservoirs, possibly in St. Thomas, and one in the Orange Hill area of Westmoreland. So we're contemplating and doing varying studies that will tell us about that sort of national infrastructure. But that's not the only steps we're taking. We're also, over the last 3 years, we would have implemented, I believe it is 30 major community tanks, smallest of which would have been 150,000 gallons, largest of which would have been approximately 1 million gallons. We expect to put in excess of 100 of these community tanks across the hilly interior of the island over the next 3 to 4 years, which will also significantly improve community storage. So that's kind of the community level program, not the national sort of major projects. At the tertiary level now, where we get to the household level, Jamaica believes firmly that every house or every structure that is built should have water storage. It is why we've changed the building requirements and why all parish councils are now asking for water storage as a component of your building approval. Now, we also acknowledge that we have a legacy issue. We have many households that simply cannot afford a black tank. It is why the Prime Minister has committed to, over the next 3 years, distributing 50,000 black tanks, none smaller than 400 gallons, to significantly build household resilience and increase our national storage in a decentralized manner. So I think on the storage area, where our storage topic, we're well down the wicket in terms of ensuring that we have adequate storage. We've spoken about distribution. On the processing side and the capacity from a water treatment plant side, we have major gaps. Our water treatment plants are old. Many of them are way past their best before date, and we have to engage the private sector to assist us. Ultimately, PPPs will have to be the way that we look at the expansion of our water treatment capacity. We have several plants which are certainly outdated, and we have several sources of water that we've never been able to build treatment capacity that would allow us to build sort of water resilience for our citizens. Notably, some of you would have seen in the media recently, groundbreaking for the Rio Cobre treatment plant to be built at Content St. Catherine. We expect this to provide some 15.5 million gallons daily to the corporate area. And as I would have said, corporate area from my perspective is Morant Bay to Old Harbour. We expect this to have a major impact in building reliability in water supply in this area, because Jacqueline would have gone before me, but she could tell you that in last year, February, in the worst of our worst drought, Kingston and St. Andrew had 8% of its 30-year average rainfall. And we were short 12 million gallons a day for that system. So adding 15 million gallons a day of reliable water supply from Rio Cobre, the second largest river in the country, literally moves you far closer to water resilience in that corporate area than you ever have been. That, coupled with the NRW work and the expansion in storage facilities, we believe we're on the right track for the southeastern quadrant of the country. But there are many areas that require significant investments, and we are indeed at varying stages, some of analysis, some of project design, some of procurement, in building in the sort of capacity that we believe you need. In St. Elizabeth, the legendary farmers of St. Elizabeth will tell you that all they've needed all this time is water to feed not just Jamaica. In many ways, they could probably feed with certain crops the Caribbean. I believe the canals are already built in the Essex Valley irrigation scheme. That's approximately $50 million. They're in procurement now for the pumps. We've done the land titling and some road work. We expect that project to have benefit, I believe, to over 1,200 farmers in the Essex Valley scheme. A major step forward in providing water to our farmers there. Now, there is another project that was announced in 1973 in a community called New Building in St. Elizabeth by former Prime Minister Michael Manley. That project is the Pedro Plains Irrigation Scheme. That project is expected to benefit farmers from eastern Westmoreland all the way to South Manchester. It would be the largest investment in irrigation in the country's history. I expect that project to run some $200 to $220 million. It has taken the country 51 years to get to the point where we're now doing the mapping, the titling, and doing the final stages of planning to start that construction. This is a project that benefited from technical assistance from the French government, and we expect to engage the contractor and start work sometime over the next 12 to 18 months. It's the closest we've ever been to making St. Elizabeth's irrigation a genuine reality. And I'm excited, not just as a politician and a member of the current government, but just as a citizen, for what that level of resilience means for our irrigation, well, rather for our farmers, and specifically for our food supply. What does this do to inflation rates that run all over the place every time you have a drought? It's truly an exciting time for that space. But we have several major water investments right through from the Greater Mandeville water treat systems, which we're midway in $4 billion of infrastructure investment. The Greater Mandeville system spans from the Pepper wells, which are the deepest wells, I believe, in the country, all the way to South Manchester. We're expecting that will be completed sometime later this year. So For any of us who have friends, family, who have even never visited Mandeville and know the water challenges they've had there, we expect to be in a way better position in the next 18 months. The Northwest Quadrant requires $209 million of infrastructure upgrades from our water treatment plants to our tanks to our reservoirs to our distribution lines from Martha Brae all the way around to SAV. So even though SAV is kind of more on the southern end, we do kind of look at it as a single integrated system. And I could go on and on the projects that we're contemplating, but what I want colleagues on the meeting to contemplate is if you add up all of these projects and all of these contemplations, you're well over $3 billion US in terms of the infrastructure that allows you at 1.2 degrees temperature rise to have resilience in your water supply. I have no idea yet, and I await the National Adaptation Plan being worked on now and the long-term strategy, which we expect completion to happen any minute within the climate change space, to tell me what we look at in the context of a 2-degree temperature rise, a 3-degree temperature rise. What I'm telling you about are the projects that we believe make us resilient at 1.5, not at 2, not at 3. And the reality is one never knows what sort of financial contemplations would have to be. Another question that comes up, and I think it's important to just state here, is we're surrounded by the sea. Why not reverse osmosis? Where water sources are not close to where we have population centers, let's just do reverse osmosis. The economic models don't allow you to do desalination at 42 cents per kilowatt hour. It's just not what we're able to do, and it does cause its own challenges. We would also have to contemplate blending that water with our fresh water. There are a number of contemplations that we do have to look at if we're really going to introduce reverse osmosis into the national water supply and not just at hotel properties as it currently exists. The last point I'd like to integrate, and Peter Clark, who I believe is also on the call, is always at pains to remind me that WRA does not necessarily get excited every time they get an extraction permit. What they would love to see us do is focus also much heavier on our use of wastewater. And philosophically, I agree 100%. Jamaica has to get to the point where its wastewater treatment is at the tertiary level and is delivering water that can be used for irrigation, for landscaping, and indeed even for aquifer recharge. It is something that we are well down the wicket. We are expecting to design a transaction. KPMG is working on that for us as it relates to Soapberry. So, in the environmental world and in the Kingston Harbour context, we always talk about pre and post Soapberry. We expect to move Soapberry to tertiary treatment in the next few years and be able to use that water in a productive way in the plains of St. Catherine all the way possibly into the plains of Clarendon. I believe I was told I was to present for 15 minutes. I think I may have gone over just a little bit. I hope my presentation has been academically sound and spurred the need for greater conversation. Thank you.
Thank you very much, Minister. Water infrastructure is indeed a very critical part of the development of water resources. And we appreciate you shedding light on the role for aged infrastructure and distribution networks in the water challenges that Jamaica now face, and the steps that are being taken by the government to develop our water supply infrastructure and build resilience. So now our next panelists that will be joining us, they are Debbie-Ann Gordon-Smith, Dr. Debbie-Ann Gordon-Smith, followed by Dr. Arpita Mandal. They'll be doing a joint presentation. Dr. Gordon-Smith is a lecturer in environmental and analytical chemistry at the University of the West Indies here in Jamaica. Her research is focused on the investigation of chemical contaminants in Jamaica's freshwater and marine waters and the impact of these contaminants on aquatic environments. Dr. Arpita Mandal, she is a senior lecturer in hydrology and Hydrogeology in the Department of Geography and Geology at the University of the West Indies, Mona. She is also an adjunct senior lecturer in the Faculty of Engineering, and she is keen. She has been teaching water resources, hydrology, and hydrological modeling for the past 17 years. Dr. Gordon Smith, you will take the floor first.
Actually, Dr. Mandal,
Okay.
we'll be going back and forth.
Okay, go ahead.
Okay. Afternoon, everyone. Dr. Gordon Smith, you will share the screen. Not seeing the slide. Right. Afternoon, everyone, and a very important topic. Right after we have seen the different climate aspects and what are the different investments going on in the water sector. So our topic for today is Science of Water Management, and we are jointly presenting it based on the research we've been doing at UWI Mona. This picture is very unique and very, very close to us. It's right from the Mona Reservoir and the intake into the Hope River, and the pictures show that in a drought period, what could be the scenario at the intake is absolutely dry, which means the level in the Mona Reservoir is very low, so that and as a result of which you get very little water in the pipeline. Next slide, please. So our research kind of tailors around the Sustainable Development Goal 6. And as we know that the SDGs are set goals that came up after 2010, where water is a fundamental right and everybody should have access to clean water and sanitation. So our research focuses on SDG 6 with further subdividing into 6.1, 2 to 6.6. Also, we try to align it to the Jamaica's National Goal 4 and the different outcomes 13, 14, and 15. And next slide will be taken up by Dr. Gordon Smith, and I'll come back again.
Thanks, Dr. Mandal. So I know people may be wondering, why are we so concerned about global water resources when we seem to have so much water on the Earth's surface? Well, I like this graphic because if we examine, and I'll use my pointer, if we examine just how much water we have in terms of our global water resources, this large blue sphere depicts the volume of water, total volume of water that we have on the Earth's surface relative to the size of the Earth. The smaller blue sphere shows how much fresh water we have, or the volume of fresh water we have for our use. And the very tiny blue sphere that you can barely see on the screen represents the fresh water that is easily accessible. If we put some numbers to these graphics, about 2.5% of all the water we have on the Earth's surface is fresh. Even less of that is available or easily accessible in surface waters or groundwaters. And in addition to that, these water resources are not evenly distributed across the globe. We can examine this further by looking at this other graphic. All the rainfall, or I should say all the water we have on the Earth's surface originates from rainfall. But 60%, or at least more than 60% of the rainwater that falls on the surface actually evaporates back into the atmosphere. So it means less than 40% of the rainwater actually flows into rivers, lakes, groundwaters, etc., known as blue water. And then most of that flows into the oceans. As humans, we withdraw maybe 9% or about 9% of total blue water. And most of this, about 70% of this is used for irrigation. If we turn our attention to Jamaica, you know this already. Mrs. Hemmings from MSJ went through this. We have a tropical marine climate or maritime climate. lows around 26 degrees, highs of over 30 degrees these days. Long-term mean annual rainfall exhibits this characteristic pattern that she talked about, where we have a high or a primary maximum sometime around October and a secondary around May. So yes, we do get rain, but it doesn't fall throughout the year. So there are times when we have some water scarcity issues, and she expounded on that. So I don't need to go back into that. But these scarcity issues are compounded by a number of factors, including climate change. We are seeing it right now. It may not be a major problem just yet for Jamaica, but it is coming and it is happening because we see an impact on rainfall, temperatures, of course, and therefore recharge into our water bodies. Water quality is another factor that is affecting our water scarcity and security issues. And this is due to improper sewage treatment, waste disposal, etc. In addition to that, we're seeing sea level rise, and this also impacts our coastal aquifers through seawater intrusion. And then another factor that is impacting our water security and scarcity is overpumping and abstraction due to increases in urbanization, which are major challenges in our cities and major towns. So this is a similar graphic on the left that Mrs. Hemmings also showed. This is our 30-year mean annual rainfall map for Jamaica. And what I want to point out, and I'll use my pointer, is that the rainfall distribution is not the same across the island. There's quite a bit of spatial variability. You see here, Blue Mountain North gets a lot of the rainfall. The West, over the last 30 years, yes, also got quite a bit of rainfall, although that hasn't been the case these last few months. But what does it mean? This variability in surface water sources in rainfall means that there is variability in surface water sources, there's variability in subsurface recharge, as well as our groundwater storage. And then to exacerbate the problem even more, the graphic on the right here shows a population density map of Jamaica. And what you'll notice is the sort of darker areas, dark brown, dark orange areas, show where we have the highest population density. How does that correspond to our rainfall map? Well, I think it's pretty obvious that where we see the highest population is also where we see the least rainfall. What does that mean for demand and supply and for water availability? I think it's pretty obvious. Dr. Mandal?
Yes, next slide, please. Okay, so now let's go into the distribution of the aquifers we have in Jamaica, the surface, which are the aquicludes and the aquifers. Now, Jamaica relies 85% on groundwater, and 85% of the aquifers are composed of karstic, highly fractured limestones, and 15% of the rest are alluvial material. So if we look at the map of the island, this is the hydrostratigraphy map based on data from Water Resource Authority, but it's primarily based on the underlying geology. So we have the basal aquiclude in the eastern part of the island, in the central inlier in the center, and also in the west, where we have a high density of surface water, rivers and streams. And then you see the yellow part, which is the majority of the island, that's the limestone aquifer. Now that is where the groundwater is. We have to, in our later discussions, we will focus on how to tap on the groundwater resources for the island, because we are seeing a depletion in the surface water, primarily in areas where there's less rainfall. And the demand for water and the exploitable water resources are unevenly distributed, as mentioned earlier, due to variation in rainfall and population. Next slide. So this was a study which was done in 2015 in a report. And what I did was I pulled out the data from the WRA's master plan, the previous one, not the latest one. And I tried to see among the 10 different hydrological basins in the island, what are the different sectors and the demand and consumption of water in the different sectors. As obvious from the population density map, Kingston is the smallest of the 10 basins, very less surface area, less rainfall, less recharge, but has the highest amount of demand, and primarily in the domestic sector. because it's the capital and maximum population density. So we have basins in the north, Blue Mountain North, and the other basins where there is an excess of water and but it's not used up. And also in the rest of the island, there is more use of water in the agricultural sector than in Kingston. So whenever now we have Negril going through a serious drought, but Kingston has always been in the forefront of drought. Next slide, please. So let us see some of the overall climate change impacts we have. We are talking about 1.5 to stay alive, and 2023 was the hottest year. It broke all records. Now, what are the offshoots of climate change, or what are the impacts that we are working with? So we have extinction of certain species, coral reef bleaching. We have decrease in groundwater level because of less recharge, surface water drying up, and so on. Next slide. Just a brief synopsis of climate models, not going into the depth of it. So how climate model and its application came up, since I'm going to talk on climate change and its impact on water sector. There were global models which looked at different scenarios of increase in population, increase in greenhouse gas combustion, growth, population, industrialization. And the scientists, the physical scientists, sat down together, looked at the different atmospheric variables, pressure, temperature, humidity, sea surface temperature, and built a model from different scenarios on what-if scenarios. So what if the CO2 is increasing? What if industrialization goes up? What if population goes up? And as a result of this, we have different scenarios which predict the future climate in the gridded level. And then in the Caribbean, we have a climate modelers group which downscale the global model into regional, and we use the outputs of that model in different sectors. I use it for the water sector, others use for the other sectors. Next slide, please. So not spending too much. Now, earlier there was the stress scenarios, A1, A2, and now we are looking at the different RCP scenarios, 2.5, 4.8.6, which shows different change in rate of the emissions. Next slide. So long and short of all these implications, which is what we have produced in the state of the Jamaican climate from the latest one, we are seeing an increase in number of dry days, increase in the minimum temperature, hotter days and hotter nights. The nights are getting hotter and hotter, less annual rainfall, less available water sources, which is directly impacting the water quality. The other flip side of the hydro cycle, so we have two extremes. One is the less rainfall, which leads to drought, and we have the increased rainfall, which is an excess. So we are going to see an increase in the frequency of high intensity, short duration rainfall. One event, a storm or a trough, and it floods out the entire vulnerable areas. And also we are expected to see an increase in intensity of the hurricanes, all of which are going to affect our water availability, infrastructure, especially infrastructure breakdown, sometimes from landslides and floods, and also turbidity and the quality as well. I think the next slide is Dr. Gordon Smith takes up.
So there are also synergistic effects. So we've already mentioned that we have these various issues that impact our water resources. But in addition, some of the impacts work together. So for example, climate change threatens water quality. As Dr. Mandal just mentioned, heavy rainfall can increase runoff of pollutants and sediment into our water bodies. If there are decreased water levels, for example, in our groundwaters because of drought or decreased rainfall, this would lead to saltwater or increases in saltwater intrusion into our coastal aquifers. The higher temperatures promote increased growth of algae and microbes, again affecting our water quality. And then overall, it affects our efforts to maintain good water quality with more intensive treatment processes required, which of course leads to increased costs. So how are we trying to help at UWI? Well, as Dr. Mandal mentioned, our research at UWI is very much based in water. So out of my water research lab in the Department of Chemistry, we have been doing chemical analysis of surface and groundwater systems and various pollution assessment studies over quite a few years now. We're also involved in a number of water tracing projects using stable isotopes, radioactive isotopes, for those of you who are familiar with that. I have my pet projects in the marine environment, and Dr. Mandal is also looking at water resource estimation and contaminant transport using modeling techniques and flood risk under different climate scenarios. Now, we can't go into everything that we do today, but I just wanted to give you a very quick snapshot of some of the work that we've been doing. In terms of assessing our water sources and contamination, we use a number of chemical techniques, including nuclear isotopic techniques. These we use to trace the origin and path of both our waters, as well as the contaminants that are carried in our waters. We also look at water chemistry, and we do this to assess the processes responsible for changes in water quality and those that affect ecosystems, as well as contamination. So there are a number of studies. I'm only going to give you a quick snapshot of two of them that we've been doing, not only as research projects at the university, but alongside some of our government agencies. Since, I believe it was 2017, I've been involved with the National Irrigation Commission on their project assessing Rio Cobre and Milk River Canal, river and canal systems. So we were looking at the sources of the waters to these rivers. And in addition to that, we were using isotopic analyses, not only to assess the sources of the water, which, as you see on the left-hand side of the slide, is mainly rainfall or groundwater, but also the source of the contamination. We have some nitrate contamination in these rivers, and I can show you right here an example of how we use chemistry to tell us about the source of contamination. We can look at isotopic ratios of nitrate in water to determine the source of the nitrate in the water, which can include soil nitrogen, fertilizers or precipitation, meaning rainfall or atmospheric deposition, as well as human and animal waste. As it turns out, in Rio Cobre, the major source of nitrate contamination is or originates from animal and human waste. We did a similar study in the Kingston hydrologic basin, but this time we looked at groundwaters because most of Kingston's water lies underground. And this work was done as a part of an MPhil study with our student. Dr. Mandal and I had a student in the geography-geology department. She graduated in 2022, I believe it was, Peter Gay Harris. She characterized the groundwater chemistry and assessed pollution in the Kingston Basin. What did we see? Many things, but among the conclusions from this study, we saw very alarmingly high levels of nitrate contamination in the basin. If I bring up back my pointer, you see these dark brown areas are well above drinking water standards. We also saw some chloride contamination, a lot of it coming from seawater intrusion. Once again, if we use those same isotopic ratios, we were able to determine along with the National Water Commission, they piloted this project to look at the source of nitrogen as well as the water in the basin. And again, major source, manure and septic waste. So I guess you must be wondering, what do we do when we collect all these data? Do we just sit on them? No, hopefully we are not just doing that. We're actually using them to make recommendations and also to provide solutions towards improving water availability, use, and combating pollution. In addition to that, we can use these data that we collect to make predictions for the future using modeling techniques. So I will hand back over to Dr. Mandal, who will tell you more about how these models can be employed.
Thank you, Dr. Gordon-Smith. So I'm going to show just a small section of the work we did for the state of the Jamaica climate for the water sector. And we used Rio Cobre Basin, which is a pet project of my PhD student, Miss Melissa Curtis, who has submitted and is soon going to be defending. But I'm not showing the entire stuff, just showing what we did for the state of the Jamaica climate. We tried to find out certain indicators which could be impacted by climate change. One of them was stream flow. Another was flooding, another was water demand. I'll show only the stream flow and the demand and not showing the flooding as that's outside the scope of this forum. So we use the climate models for the different RCP scenarios, and we conditioned them over hydrological model, which was developed using physiographic and geospatial data sets. And we tried to model future stream flows of the Rio Cobre and its different tributaries under different climate scenarios. So 2.5, 8.5, 8.6, 4.6, 8.5, the standardized 3 scenarios we used. The techniques we used were modeling tool SWOT, which is soil water assessment tool, to simulate the rainfall runoff. That is, what would be the runoff if the rainfall is down by X percentage or is going up for the upper and lower Rio Cobre. We also tried to assess the impact of demand and supply relationship on the water resource using the water evaluation and planning tool for different projections and different time steps. Next slide, please. So that is the Rio Cobre watershed management unit on the right, and on the left you have the different watershed management, the hydro basin, sorry, and we are focusing only on the upper and the lower Rio Cobre because the rest of the sub-watershed management units within the Rio Cobre watershed management unit does not flow to the Kingston basins. The objective was trying to see how much of the water can be extracted and the sustainability, because we are all discussing about bringing in water from Rio Cobre. And currently there is pipeline from Ferry that brings in water. But what happens if the temperature goes up, rainfall goes down? So we're just focusing on the upper and the lower Rio Cobre watershed management units. Next slide. Now, the upper and the lower Rio Cobre, if you look at the rainfall distribution, again, there is a clear spatial variability. The upper Rio Cobre is receiving much more higher rainfall than the lower Rio Cobre. Brown, which is in the rain shadow of the Blue Mountains, is already receiving less rainfall. And you have more population in the lower Rio Cobre because Spanish Town, Portmore are the 2 major towns in the parish of St. Catherine. We're trying to do the rainfall assessment from 1995-2018. We did until 2018 because of the availability of data and the time period we looked at. We did see cyclical 10 years up and down cyclical trend, which is normally seen in the rainfall data. Next slide, please. So what is SWOT? SWOT is a soil water assessment tool. What it does is it predicts flows, so you can model flows in different river systems with data such as topography, watershed data, soil data, land use data, elevation data, rainfall, evapotranspiration, all the different climatic and non-climatic factors. It works in ArcGIS background. So the primary data you need are all given in these pictures here, which is the DEM, the data sets such as climate, rainfall, and feed into it. You delineate your watershed, you separate the watershed into sub-catchments based on soil and land use, and you put in your rainfall and the other climate, and you can predict the flows. Modeling is useful because not all the rivers in Jamaica or for anywhere in the world are gauged. We cannot have gauging stations every single location we want. Ideally, yes, but we don't have it. So if you're in a watershed or in a catchment or sub-watershed where there is no gauging station, how do you know what will be the flow of the river in 10 years? Or what was the flow back 5 years back when we had the drought? We don't know. We go by anecdotal evidences. So that's why we in the department is trying to promote and develop these modeling techniques which can help in decision making, so that if this model is set up for any basin, all you need to do is change the rainfall, change the land use pattern if there is any significant land use, and you can click simulate and you can simulate the flows. What will be the flow if 50% is urbanized? Next slide, please. So that's primarily some samples from the Rio Cobre. So we used the DEM, the elevation data. We extracted the catchments, the river systems, and the junctions of the different tributaries where we are trying to simulate the flow. Rio Cobre is well managed and has a well network developed network of stream flow stations, but not every single tributary is measured. So if we want to take off water, let's say from one where we don't have any data, then we try to go into modeling as well as for other reasons too. Next slide, please. So what we did is we used the gauging station rainfall data from the existing gauging stations, the Met Office stations, and we use the daily stations, not the intensity one, because we are not looking at intense events. And if you see here, the upper Rio Cobre, we have a lot of stations. Lower Rio Cobre, we just have one station. So we ran the model using the data, rainfall data for the upper Rio Cobre, daily rainfall for all that 12, 15 years in daily time step. And then we use the RegCM 4.3.5 20-kilometer grid box climate data from physics, climate studies group physics. So Rio Cobre would fall into the boxes 5, 4, 13, 12. So we use the gridded rainfall data and ran the model using both climate and the historic climate data, the present climate data, future climate, and also the existing rain gauge stations, and found the flow at the different tributaries, which is Rio Pedro, Rio Cobre at Williams Field, Rio Cobre at the Gorge. Just show you some examples of the outputs. Next slide. So what are we seeing is that on the left, on the blue figure, is the model rainfall from the grids, and then how the rainfall trend has declined. So we are seeing in the total annual rainfall in the upper Rio Cobre, grid 1 and 2 are basically the two grids that cover it, are showing a declining trend. So overall, there is a lowering of rainfall, which is on the left-hand side, and on the right also, as a result of which rainfall declines, the stream flow will be declining as well. But after 2050, we are seeing a slight increase in stream flow until the end of the century. That's Rio Cobre near Spanish Town, Boardwalk, and Rio Magno. But overall, if you look at a trend analysis, it's just showing a decline in the daily stream flow. This was done daily, and then I'm showing the yearly data set over here. Next slide, please. So what we did after that, we used the outputs from the SWOT and fed into the WEAP. Now, these lines and dots which you see here are the different demand sectors which we estimated based in consultation with NWC on what are the zones and the demands. So it's not, so the dots are not, every dot is not a farm. So we kind of collated all the farms as an agricultural demand. In lower Rio Cobre, you have both agricultural and commercial. In the upper Rio Cobre, we have more of the agricultural demand. And the tributaries also, you digitize it and the gauges. So you take the model outputs from stream flow for the different scenarios from the SWOT, and you take in the groundwater abstraction from the data available, and you try to model the demand for the urban, rural, and agricultural sector for different scenarios. And that the data which you see here are existing from the WRA Water Resource Development Master Plan Draft 2005. This study was done for SOJC, and that time we didn't have the master plan, so it's a little bit old. Next slide, please. So what we are seeing is that we are seeing an increase in the potable water, both in the upper and the lower Rio Cobre. Agricultural demand, consistent increase in with an increase in growth. We tried to say, put a percentage, 5% growth in population, 5% growth in agriculture, just some scenarios, 10% growth. We are seeing an increase in demand. But remember, we are seeing the increase in demand, but we are seeing a decline in the stream flow. So we have to look for more other sources, primarily the groundwater. And that is what I'm going to end this session on. Next slide. So with a growth of 1.5, 3%, we are seeing a decline of 2% to overall 2 to very low in the upper Rio Cobre. Now, hydrogeologically, upper Rio Cobre is mainly limestone, whereas in the lower Rio Cobre, you have alluvium and a little bit of limestone. So if we tap into the wells of the limestone aquifer, which is a thick limestone aquifer sitting at the top of the upper Rio Cobre, we think that it is possible to extract more water from the wells than just depending on the surface water sources. the PhD research has gone more into mod flow and other modeling, but due to time, we are just showing a snapshot of it. Next slide. So based on this study and the climate impacts projections and their conditioning, we are trying to say that we need new sources of water supply, which Minister Samuda mentioned as well, and others would agree that we need new sources. But how do you find these sources? And what are the aquifers we should be tapping into? We should tap into, I strongly feel that we should tap into underground water resources, because 75% of the island is filled with aquifers. So for the Rio Cobre Basin, I believe that the limestone wells in the upper Rio Cobre, and also they are away from saline water intrusion. They are further away from the coast. So there are less chances of contamination from the chloride. And that is what we are trying to project over here. And also looking at the contaminants in the limestone and alluvium wells over here, we have seen less contamination in the limestone wells. They are deeper than the alluvium wells. Thank you. That's leave some finishing comments with Dr. Gordon-Smith.
No, I think you covered it all. Thank you, Dr. Lester.
Thank you. Thank you, Dr. Lester.
Thank you, Dr. Mandal and Dr. Gordon-Smith. Research really allows for the discovery of solutions to problems, and it also drives innovation. And so I really want to thank you for sharing such a data-rich presentation on the science of water management and the contribution of researchers from the Faculty of Science and Technology here at UM-Mona in addressing some of the water challenges that we have here in Jamaica. So I know you have many questions. We have not forgotten about your questions. We will take your questions at the end. So continue to post your questions to the chat. So our next speaker will be Miss Leanne Spence. She is the co-founder and operator of Instant Save Conservation Solutions Jamaica Limited. And alongside her team, she has developed innovative solutions that have saved millions of gallons of water in Jamaica. She is a certified water efficiency professional with a passion for education and background in international business. She champions programs aimed at fostering water efficient technologies and behavior change across workplaces, schools, and homes. So today, Ms. Spence, she will be sharing with us on innovation and advocacy for Jamaica's water future. Ms. Spence, you have the floor.
Thank you so much. And thank you to the UE Faculty of Science and Technology. It's very exciting to be here. Very interesting presentations, and just happy to be a part of this discussion. So my presentation for today is titled From Scarcity to Security, How Are We Going to Build Jamaica's Water Resilience? And we're purporting that we're doing it through empowering Jamaicans through demand-side management. Now, the science is undeniable, right? Our experts in this forum have painted a very clear picture. Jamaica is experiencing scarcity, and the minister had mentioned that, you know, often as a result of uneven distribution as well as aged infrastructure. So we know that there's a significant amount of investment that needs to be made into our water infrastructure. But the question becomes, how can we, as Jamaicans, as citizens, now empower ourselves to move beyond to security for the future? Now, over the past 10 years, our company has been focused on just that, an efficiency-first approach called demand-side management. Now, demand-side management is really considered to be a strategic toolbox, right? It looks at how do we do behavior change, how do we utilize efficient technologies and financial incentives to promote water use, curb consumption, and then thus ensuring a sustainable water future. Now, when we talk about water, sustainable water use, of course, we have to discuss the both sides, right? And in the prior presentations, a lot of the discussion was around increasing the supply, making more water available. So we would like to add our piece about the demand side because both are necessary. So the goal of sustainable water management is to ensure that we have enough clean water to meet the needs or current needs without compromising our future needs. And of course, as I shared, this is going to include protecting our water resources, ensuring that they're of quality as well as availability, and then managing that demand, and that is using the water as efficiently as we can. Now, in our National Water Sector Policy of 2009, there is a note that says demand-side water management is faster, cheaper, or more cost-effective, and an environmentally friendly solution. So let's just look at what we've been doing for the last couple of years at Instant Save, and I want to just share some findings with you. So when we talk about demand-side management, we're really talking about household use, we're talking about commercial use, we're talking about agricultural use. And very often when we walk into buildings, because one of the services we offer are assessments, we're finding that 3 out of 4 homes that we walk into are still inefficient. They're still not where they can be in terms of the standard of efficiency, in terms of technology that is available to ensure that they're using the water efficiently and reducing their costs. And likewise for businesses, 9 out of 10 businesses that we do inspection from have similar issues. The fixtures are not at the standard of ultimate efficiency, and they're still experiencing a lot of leaks. So we know that the challenge that we have with water management, it has to be multi-pronged. We have to look at everything that we have been discussing in this forum to really tackle the issues related to water. So just some leaky facts to share with you. One running toilet can waste 11,000 gallons of water per month. Now, I wish I could see everybody in the audience because I would poll and ask, have you ever experienced a leaking toilet in your home? I figure a number of hands would go up because we get calls all the time. Flapper balls are big culprits for toilet leaks. And that can result in a loss of not only a wastage of water, but a fundamental impact from the financial sense. That translates to 14,300 Jamaican dollars, and that's without sewer. Because sewer, when you add sewer, it basically doubles your water rates. So that is something to consider as well, that the amount of water you consume is going to be directly proportional to how much the related cost incurred to produce that water and pump it, distribute it to you. Similarly, for shower heads, we're still finding that shower heads are using 10 gallons more on a 10-minute shower than they need to. And then another small thing that will happen that we don't even realize happening in our home is diverter leaks in the shower. They can waste 1 gallon every 40 seconds. So just imagine a 10-minute shower and how much water you use. So we really want to bring it back to what can we do as citizens? And I would always, purport that the first point of contact, because we cannot manage what we don't measure, is to look at your water meter and your water bill, right? You need to know how much it is that you're consuming on a monthly or daily basis, right? And how much the associated costs are. And then you look about avenues to be able to reduce that. And the water meter serves as an excellent tool as well to pick up if you do have leaks on your property. So in terms of water efficiency, we really want to look at water management on a whole, right? And there are a number of technologies that are available that Jamaicans are using in homes, in businesses that are achieving great levels of efficiency. And they're paying minimum amounts of money on their water bills. So, it's a win-win. They're very happy because it's also supporting the fact that there's less burden on our national resources. So leak detection is a good starting point in terms of reducing your consumption, because very often, as shown in the prior slide, leaks are happening and we don't even know. You're paying for it and you don't even know. So there do exist smart meters, there do exist Internet of Things sensors that can be installed on your systems, as well as leak detection services where persons can come into your home and help you to trace your pipes, identify the area in which a leak is happening so you can find and fix it. We have received a number of calls since that earthquake last year where the shift underground created some disruptions in the pipelines. So, people are ongoing with maintenance to ensure that you're keeping your checks on your leaks, because very often what happens is when you get a bill and it's $100,000 and your normal bill is $2,000 or $3,000, that's usually at that point when it creates an alarm. But if you had been keeping on top of it, ensuring that you're doing your regular checks, then you wouldn't have to wait that through a bill cycle to find out. Another technology that is very, very efficient are the use of high efficiency plumbing fixtures. Now, high efficiency, and I'm going to show you a chart in just a few minutes. High efficiency refers to international standard of flow rates or flush rates by which a fixture should use. And that is the benchmark you use to determine whether or not your fixture is efficient or not so efficient. And this would apply for your toilets, your faucets, your shower heads, your dishwashers, and your washing machines. So this is the guide that we use in our business and that we encourage you to look at as well. For these various fixtures, you want to ensure that when you're purchasing them, that they're meeting these standards. For your toilet, 1.28 gallons of water or less. And it continues, right? And there are various ways that we can help you to measure these things so that you know whether or not you fall into efficiency. And I'm not seeing any faces, but I'm hoping persons are going, oh yes, that's something I need to look at. Other technologies that exist are smart irrigation systems. So agriculture does use, as mentioned before, 70% of our water. So the use of our irrigation systems for our farmers is very important, utilizing sensors to monitor soil moisture level and to emit the water in just its correct amounts to be able to generate our crops. Gray water reuse systems are also, so gray water reuse and rainwater systems are considered supply side because you are creating or making more water available, but certainly this aids in the entire water management process. So gray water is really what the water that you collect from your baths, your showers, and your sinks. Does not include your toilet water. And you are able to treat it to a certain extent and then reuse it for non-potable uses. Rainwater are systems that collect rainwater from your roofs or other surfaces, and then you can store it for later uses, such as your irrigation, your toilets, or your laundry. So this is just a sample of what a household, or we can extrapolate to businesses as well, can look like if they're integrating different efficient appliances, processes, and behaviors. So we're seeing, if you start from the top, we're seeing where the rain falls on your roof, it's channeled through the gutters, enters into a system, a rainwater tank that can be a blank tank on the surface, a rain barrel, or an underground cistern. And then that is used on the property as you see fit, whether it's for irrigation, whether it's to wash your cars, or a non-potable use. Certainly, if you're going to have it re-enter your home through dual plumbing, then it becomes important that you treat it to that quality level. So you have to go through various amounts of treatment before it reaches to a drinking level. You still have your municipal or utility supplied water. And once the water is used, it can go into a septic tank and go through processing, or you can have it in another gray water recycling tank and use it for irrigation as well. The houses would always also be fitted with water efficient appliances. That's the toilets, faucets, the shower heads, ensuring that they meet the required standard. And then that's what you're looking at as a sustainable unit. So demand side management really has significant benefits, right? It has the economic benefits, that is lower water bills for you, us as citizens. It means we're paying less money on our water bills, and we're making it available to do other things, right? And keep in mind that your water rates are increasing over time, as well as there is an energy water nexus that was mentioned earlier, because inherent in every gallon of water that's produced is an energy footprint. So if you have a water tank on your property and it's connected to your pump, of course, and you have a leak in your home, so your toilet is leaking in your home, the utility is not supplying at the moment, and you're relying on just your water tank. Can you imagine that pump will be continuously running and depleting your limited water supply? So you'll have that energy footprint as well as wastage of water, all because of a leak. So it's very important to consider these things because the water treatment and pumping process for distribution is very energy intensive. It also improves productivity, less closure of schools, less closure of businesses. When you are more efficient and you've built a sustainable water system for your property, your home, or your business, it creates that buffer as well when we're going through times of water shortages that you can still be operating during that time. It also increases property values. Then from an environmental sustainability point of view, of course, we're putting less pressure on our natural resources and less strain on the aged infrastructure that we were discussing before. And then simply from a convenience side, it increases our resilience and our water security because we have less disruptions and we have more of a consistent supply. And of course, we need a consistent supply to operate the various sectors of our economy, including the public health, schools, or businesses. Now, for us at Instant Save, we've been able to help homeowners implement efficiency in their properties, and generally, on average, we help them to save about 30% on their water consumption. And the same is true for businesses. Through just implementing, whether it is a hardware retrofit that is changing out the fixtures or leak investigation to identify areas that are using more than they should, changing processes, changing behaviors, implementing rainwater systems. We help companies, and you're seeing where they're achieving like up to 70% reduction in water use. That corresponds with lower water costs as well. So the results are proven, and there are many persons in Jamaica that have adapted and are seeing the benefits of water efficiency. So I did a little calculation before because, when we're talking about the need we absolutely need significant investment in our infrastructure. And, storage is an issue. These were discussed. But I will also add that water efficiency and conservation can be a new water source as well. With a population of 6,700 persons, according to Stanton in 2018, in Kingston and St. Andrew, using 40 gallons per person per day, if we were able to just save 10% of that amount, 10%, just through very simple changes like we mentioned before, looking at our flush rates and our flow rates, making those adjustments, fixing our leaks, saving just 10% every homeowner. At the end of the year, we would have made more water available in the amount of 985,200,000 million gallons of water, right? So that would be available. And that is actually more than the capacity of our Mona Dam. So it would be like we're creating a new dam, So it's really important that we look at it as a strategy to be able to better manage our water resources. And we're always advocating for change. Minister Samud and I, we've spoken, and we're having those kind of discussions. It's very important that the kind of fixtures and the kind of technologies are not only available on the market, but that they're incentivized, and that they're meeting standards, international standards of efficiency, and that they're labeled. So when you go into a hardware store, plumbing shop, wherever it is that we're going to be purchasing these items, that is clearly marked, so what is efficient and what's a quality item from what isn't. So clear labeling allows you to readily identify those options and make informed purchases, and that is very, very important. Information about educational programs. Also important that information is be transmitted so we can be empowered to make decisions related to how we invest our money to contribute to the efficiency of our water resources. And then the creation of incentives, offering rebates and tax breaks. The incentives that we have in Jamaica now are very, very limited, right? And I do believe that if these incentives were actually mandated, installed, then you will see where there's a greater adoption to these technologies, that persons would very willingly invest in them and have them installed. So that's something that we really need to advocate for. So I would love all individuals, all the citizens here that are watching, to become water ambassadors. I didn't come today and speak about taking a shorter shower and turning off the tap when you're brushing your teeth. That's very important, yes. But generally what we find, particularly when in our approach, is that efficiency approach, technology first approach means that even with little behavior change, you can still achieve great results just by changing out your technology and investing in solutions to help you to capture your rain, use it efficiently. But so become water ambassadors, share the information that you've learned through this forum with other persons, and go ahead, do the research, call us up, look at what is in your property right now, and start thinking of ways to become more water efficient. And for businesses, the very same thing. An investment in water efficiency not only reduces costs for your operation, but it demonstrates your environmental leadership. And then, of course, with the government, we're always open to collaborating on this demand-side management approach and just encouraging you to incentivize the use of these systems for adoption in Jamaica. Now, before I leave, I wanted to put out just a little challenge for persons that are on, and it's a flow rate challenge. So the tools that you're going to grab, I don't know if you're home yet or on your way home, but when you get home this evening, grab a measuring cup and a timer that can be your phone and just do a 10-second flow test, right? So you're going to place the measuring cup under your shower or your faucet, and you're going to turn it on for 10 seconds, shut it off, and then look at the volume of water that is collected in that 10-second test. Once you've ascertained what that volume is, multiply it by 6, and you have your flow rate. Now, again, your flow rate can be gallons per minute or liters per minute. That depends on what's on your measuring cups, right? But generally, as a guideline, on the right, you can see that an efficient faucet uses 1 gallon of water or less per minute, or 3.8 liters per minute. And an efficient showerhead uses 2 gallons or less per minute, or 7.6 liters per minute or less. So use that as a guide. And let us know, I'd be curious when you do that test, what your findings are. So we are here to help. We offer water use audits and build rainwater systems, leak detection services, and the installation and supply of water-saving kits. So together, it's really just important that we advocate for water use efficiency, and through the combination of smart demand-side management techniques coupled with investments in infrastructure and developing our supply side, I know that we can ensure that Jamaica becomes very water secure and we save every drop. So thank you very much for having me. And I look forward to the questions and further dialogue.
Thank you, Miss Spence. You know, earlier, Mrs. Spence Hemmings, she asked, do you think that only the government is responsible for finding solutions? And here we have you presenting solutions, demonstrating how every citizen can contribute to water use efficiency. And there are endless demand-side strategies that can be implemented in our homes or businesses, on the farm, wherever we work, play, live. And so we thank you for that insightful presentation on what we can do as citizens to alleviate some of the stress that we feel associated with our water scarcity and security challenges. All right, so we are coming down nicely. We should have Mrs. Hardware, who is our final speaker. Mrs. Hardware, if you are online, you can indicate. Okay, no. We had invited her to speak on bottled water and the water crisis. She's a lecturer and an environmental health program director, but possibly due to certain circumstances, she was not able to make it today. So we will delve into the questions that were posted in the chat. And the first question goes to our first presenter, Mrs. Spence Hemmings. The question is, what is the long-term outlook for Jamaica's drought cycle?
Did they specify by long term they're referring to this year or decades from now?
Well, I think that you could give insight into the long term in terms of maybe to 2030 and then maybe mid-century. They did not specify, they just mentioned long term.
Yes, so for this year, we are expecting that we should see relief, and we have started getting rains. We're expecting that we should start seeing relief by the end of July for this year, and by October, we're expected to be back in the green, if you want to call it that. And but over the long term, the projections for climate change are showing that we continue to see that variability, that change in our rainfall patterns, and a shifting where we're seeing Portland, for example, is now getting less rainfall. Portland, we didn't think of Portland as a parish that had drought in the days gone by. Portland is now seeing periods of drought, and actually on the west, they seem to be getting a little more rainfall. So there's that shift, and this was projected in the State of Jamaica climate report that was done by the Climate Studies Group. It was mentioned in the presentation by Dr. Mandala as well. So long term, the variability is going to continue. The changes are expected, and it's going to increase over time. So unfortunately, it's not a good picture, but rainfall is rainfall is one of those parameters that's quite hard to study. And the variability that is coming is only going to make the challenge that much, worse. But, with good management, we can do it.
Okay, thanks for that answer. So the follow-up question is, what about air-to-water technology and its use for household water? What are your thoughts on that? Mrs. Spence Hemmings, that question is for you.
Okay, sorry, I'm not sure what is meant air to water, if they're referring to cloud seeding, or I am not sure.
Okay.
If I
Leanne,
can,
would you be able to give any insight on that?
sure. So we would be in our early stages of research, but air-to-water technology is really focused on creating water from air, as it says, right? But like projects similar to desalination, it does require significant investment, and it does have some implications on where geographically the equipment is used. So the research continues. I'm not sure if our government has started to look at that yet. From our experience, I haven't seen where anyone has implemented a solution, but certainly it's a technology that persons have their eyes on. But from a cost benefit point of view, I think that is what is being explored right now.
Okay. So we have a few questions for the Honorable Minister. Let me just check if he is still with us. Or we will go to questions for Doctors Gordon Smith and Mandal, and we'll circle back to those questions for the Minister. Dr. Gordon Smith or Dr. Mandal, is there a way to decontaminate the existing groundwater resources?
That's an interesting question. When you look at the sort of scale you'd be thinking about, that would not be the easiest task. The first thing we would need to start with is to stop polluting the water resources. I think that is really where we need to start. And we can do that in many ways. I mean, we can, Leanne went into some of the ways as well. We should be reusing more of the water that we're paying for. And of course, we should be treating our wastewaters. And the minister alluded to that as well about the expansion to Soapberry that is planned for Soapberry. Cleaning up the water, all of the groundwaters in Jamaica, which is quite a lot of water, although not all of it is polluted or contaminated, I will admit. There are pockets, like Kingston Basin, of course, has an issue. That is something that I think would be beyond scope for any of us here. Certainly, though, we need to start by by cutting back on the pollution or the contamination that is going into our groundwaters. To use the water, yes, we can. We can actually use the water, even though it has high levels of contaminants. The problem is the cost of treatment. As I mentioned, once water quality is degraded, it requires more sophisticated, more expensive, more energy-intensive treatment. And that is really the problem on a wide scale to supply, for the National Water Commission to supply water to Jamaica, that they have to carry out this expensive treatment on. It's not really feasible at this time.
Okay, thank you. Mrs. Spence Hemmings, are there any environmental studies to support the planned irrigations expansion that the minister would have mentioned earlier? Do you know of any study that is looking at the impact of pumping out X gallons of water on the ecosystem?
No, sorry, that's that does not fall under the mandate of the Meteorological Service. That is more National Irrigation Commission or NWC.
All right. Dr. Mandal, what are the key data gaps that need to be closed to better manage Jamaica's water resources?
Okay, very important top question. One of the key key data gaps is inconsistency of data. Some years you have, let's say, basic contaminants, nitrate and chloride in the well. Some years you have the wells being monitored and you have the data, but then there's a huge gap and then you have it back again. So there needs to be a consistent monthly monitoring on all the wells, because if you want to tie it to, this is what me and my colleague, Dr. Gordon Smith, we are often try to think, as more and more houses get connected to the sewage treatment, is there a decrease in the level of nitrate? Is it improving? Do we have a trend? But to do that, we need to have a long-term history of data. Same thing for the stream flow. Well, most of the larger rivers in Jamaica are well monitored and there are stream gauge stations, but there are some rivers where they flood a lot, and it's a different topic from water, but since you're from water resources, but since the question is on data gaps, there is no data on the stream flow of some of the rivers where it floods a lot. For example, Port Maria, we don't have a stream gauge data, so there's a lack of data. Rainfall, yes, we have upgraded a lot of our med survey stations, and there are a lot of AWSs are coming up, and myself and my colleagues have also installed through the Magic Rio Mino project 2 AWS stations, but there is a gap still in the earlier data sets. Let's say, why did we start from 1992 and not from before? Because there was no data because of a fire. And even from 92 to 2018 and going on to 2024, some months, some stations, and for some years, we had to remove them because there's just 1 or 2 points in the data set. So active monitoring, upgrade of the stations, maintenance of the stations, very important. Both Met Service and the WRA stations often get affected by flash flooding. So we need funding to keep them up and running. So I should say hydrometeorological network is improving and needs to improve more, because without good data, the models will not give good results. There will be a challenge in calibrating the model, because anything you can put in and the model will show outputs, but what is the validity of the model? How sustainable are those? So we need to calibrate. And what do we calibrate with? With observed data. And if we don't have observed data for specific periods, then we have a challenge with calibration. That's all I can say, the data gap, both from monitoring for quality and monitoring for stream flow, and the hydromet network needs to upgrade.
Thank you, Dr. Mandal. Desalination keeps coming up. And so can any of the experts on the panel share insights on pursuing desalination as a means of addressing Jamaica's drought issues?
I think the minister really also mentioned that as well. It is certainly we live on an island, and it would be something that we would love to be able to pursue. But given the cost of energy in Jamaica, it is not feasible, or certainly we can't see where it's feasible at this time. I know that there are, various agencies or times when it comes up, and we do, examine it. But at the moment, so far as we know, it is not something that is feasible right now, unless we can decrease those energy costs.
All right, thank you, Dr. Gordon Smith. I am checking to see if we have, okay, so we have another question for Ms. Leanne Spence. Are there discussions with the government for ensuring the incorporation of these water recycling, rainwater harvesting, and efficient technologies in new buildings, especially the high-density buildings?
There are absolutely discussions taking place. However, at the point at which it becomes further from policy to be mandated, where it's enforced on the ground, we have not gotten there just yet. But to answer your questions, yes, there are discussions taking place. And I would just continue to encourage your advocacy. So the same way you have come and asked this question, when you see the minister and the relevant personnel or stakeholder meetings happening, town halls, please bring up this question again so that the dialogue can continue, because I do believe that, the implementation will happen when enough of us join together and say it must happen, right? So we, in fact, need to not only from our current situation, do what we can do in our own sphere, but on an advocacy from a community and citizen point of view, please continue asking that question to our officials and persons who can make those changes, because as the minister had said before, we have this age infrastructure and it's not aligned with the rate at which we're developing. And you're right, a lot of new developments are going up almost seems overnight, right? And they're creating stress on our existing infrastructure. So an excellent question, and discussions are happening, but it's difficult to say a timeline in which they're going to be, get to where we really want it to be and where it's necessary.
Thank you. Another question for Mrs. Spence Hemmings. It is expected that we will surpass 1.5 degrees by 2025. And you spoke earlier about some of the initiatives within the Ministry of Economic Growth and Job Creation. Do you think that we may be close to limits of adaptation based on the rate that climate is changing? How far into the future do you see some of the initiatives that we are implementing now? How far into the future will these serve us?
Limits to adaptation varies, so that's a very broad question. And different sectors will have different responses to that. So some countries will tell you that they're seeing limits to adaptation in certain ecosystems. Jamaica is probably not there yet. I couldn't say how far, because as I said, that is outside the scope of the Met Office. But I don't think we should even be looking to get to 1.5. We should try to stay where we are right now, because if 2023 was anything to go by, and if that's around 1.2 on the global scale, remember that when you look at the local, that can be an increase of 2 or more degrees for you at a national level, because the global level is not speaking to what is going to happen. Nationally, Jamaica is already a tropical climate, so we're already hot and we're just getting hotter. So, I don't even want to look there, to be honest. I really just want to stay within the 1.5, because I really don't think we will be able to manage at all. But Beyond 1.5, we know for sure a lot of our ecosystems will not be able to survive. The IPCC reports, I mentioned the Intergovernmental Panel on Climate Change, so persons can actually go on the website to see those reports, and they speak more to some of these limits to adaptation, you know, what will happen, what is happening in some instances, and therefore why we are saying 1.5 to stay alive, especially for small island developing states where Jamaica is an island. I don't know about you and swimming, but if you think about it, we have no place to relocate to because we're surrounded by water. Issues of migrating to other countries is not so easy. You know, so let's not go there. Let's not think about limits to add. Let us just try to fix the problems now as best as we can and see how well we do there and, you know, move forward. But as I said, additional information is available on the ipcc.ch website.
And I would encourage everyone that is participating in this forum afternoon to engage that information, to engage publications like the State of Our Climate report so that we can all be aware of what is happening and how it is and will impact our daily lives. So we have come to the end of another wonderful series and tackling Jamaica's water woes. I want to extend a heartfelt thanks to our panelists, the Honorable Minister in his absence, Doctors Gordon Smith and Dr. Mandal, Mrs. Spence Hemmings, Miss Leanne Spence. Thank you for taking the time. Thank you for your valuable contributions, the insights, and the dedication to this important cause of tackling our water-related issues. Throughout the discussion today, we heard from a wide range of perspectives. We heard about the current state of our climate and the projected changes, 1.5 to stay alive. We heard about the factors that are affecting our water security and how we're using science and research to contribute to solutions. And Ms. Spence provided us with how we can play our part as citizens. We can manage our water use efficiency better. And so it is clear that we can be on a path of more sustainable water management if we work together. It takes coordination, it takes participation from each and every one of us, from the private sector, from academia, from children in schools, and at the policy level as well. I encourage each of you who joined us today to share these insights within your respective organizations, within your communities, and let us continue to collaborate and innovate for change so that we can ensure access to clean and safe water for everyone in Jamaica. Thank you for joining us today.
Thank you.